And greetings and welcome. So we're looking at last night's homework. This is page 524, problem 21 from our Algebra 2 book. And we were talking about finding compositions of functions. I guess it would be valuable for me to talk about what we're finding here instead of just giving two functions. So I was trying to find f of g of 3 for starters. Your book wrote it using a different notation. I'll write the second part in the different notation just so we're familiar with both. But the way this works is you start with the innermost value, plug it into that one, and then take that result and plug it into that one. And even if I have like a chain of like 5 of these nested parentheses, you just start with the innermost value and keep kind of working your way out slowly. So in order to there we go. In order to figure this out, the first thing I'm going to do is figure out what g of 3 is. And it just means I'm plugging in 3 for x in g, so 3 squared. And whenever you substitute or plug in, you should probably use parentheses. So that's 9 plus 6, right? And I'm going to get 15. So that's what g of 3 is. So I'm now replacing g of 3 with 15, and I'm going to figure out what is f of 15. Okay? So we will have 15 plus 1, which is 16. Meaning f of g of 3 is 16. So part 2 of this problem was g of f of 3. So they did it backwards. And this is using the different notation. This is not a letter O. It's, I believe someone said yesterday, a degree symbol that's kind of like mid-aligned vertically, if you want. It's about that size, right? It's the location of a multiplication dot, but it's not a dot, it's a circle. All right? So, and that's read as g of f of 3. It's the symbol that represents the operation of function composition. So g of f of 3 means I'm taking 3, plugging it into function f. So f of 3 is equal to 3 plus 1, which is 4. And now I'm going to take that and plug it into function g. So g of 4 is going to equal 4 squared plus 6. So that's 16 plus 6, which is 22. So g of f of 3 is 22. All right, so you just kind of follow from the inner, or the furthest right, I guess, and keep plugging it in one way after another, right? So function composition. Now, there are a lot of different ways of representing functions. One of them we only saw in the classwork yesterday was 23. And this is representing it as kind of a set of ordered pairs. They represented each function. So they want us to calculate the same thing. So this one's going to be a little bit more visual in the sense of the work. So f of g of 3. By the way, I like making my inner parentheses shorter than the outer parentheses. And then if there's even more, I just make those parentheses even larger, right? So it's, and then I also think that looks like some sort of like cell phone signal bar. But I don't know. So f of g of 3. So if I want to figure out first what is g of 3, that means I'm plugging in 3 for this function g. And this gives me a set of ordered pairs, and it says when 3 is an input, -1 is the output. Okay? So that's what that represents. And now I need to figure out what is f of -1. So for function f, if I plug in -1, I get 9. So f of g of 3 is 9. And then g of f of 3. So let's figure out what f of 3 is. So I plug in 3 for f. The output paired with that is 6. And then I need to figure out what g of 6 is. And when I plug in 6, I get 12. Right? So it's just kind of like following the little chain sequence sort of thing you're doing. Plug in 1, get the output, sort of thing like that. So yeah, so there's 23. So I think the difficulty there was just the notation. We weren't used to it in that format. If I did have this set up with the crazy kind of oval input-output things that they have, G would have been -5, 6, and 3, and the outputs would have been 3, 12, and -1. So the function g would have been this. All right. Right. Not very interesting in that case, but yeah. So that's what the function g would have looked like in that format. Right. All sorts of things. And today we're actually going to talk even a little bit about the graphs of these functions and how they relate to one another as well. Let's see. And then the last problem, what was it? 30-something? 39. Oh, classic. Actually, I might need to grab that whole, yeah, I'm going to just snapshot this whole thing right here. It's not like it takes up that much more data. No more bits were wasted, really. Dun, dun. So here we go. So 39 wants us to calculate f of g of h of x. Whew, classic. So f of g of h of x, the first thing I'm going to want to figure out is, what is h of x? Well, I guess. Yeah, let's do this. Now, they're not having us plug in a value here, are they? They're just having us plug in x. So that means that we're actually going to be given a function back. So f of g of h of x would have been like, I talked about yesterday, that would have been like the TV, VCR, DVD player, like all of those things just like mashed together, or we're like literally taking the h function and pushing it into the g function, right? And then taking that and then like cramming that all into the f function. It's going to be crazy. So h of x is x minus 1. So if I want to figure out g of h of x, that is going to be, well, g of x is 4 times x. So that's 4 times, and instead of x, I'm replacing its insides with x minus 1. All right? So let's figure out what g of h of x simplifies to be. And that would be 4x minus 4, I believe. And now I want to figure out what is f of g of h of x. So f of g of h of x. And so function f is the x squared function. So whatever I get, I plug in and I square it. What am I plugging in at this time? I'm plugging in g of h of x. So I'm taking this and plugging it in. So 4x minus 4. And I can't just distribute a square over subtraction, so I'd have to maybe use a pattern or FOIL it somehow. So this is going to be, I believe, I'll use the pattern, 4x squared minus 2 times 4x times 4 plus 4 squared. All right, when I use the square of a binomial pattern, and this is going to be 16x squared minus 32x plus 16, I believe. And blah, 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 39. That is the answer in El Libro. So I believe we are good. So that was last night's homework, talking about function composition. Very good.